Alright, in this video I'll be discussing the velocity of Debroglie waves. In our previous videos we have had a discussion on the dual nature of material particles. What Debroglie predicted is that material particles can have dual nature, as it was experimentally confirmed that radiation has dual nature. So to just discuss out this Debroglie waves, let us start with the Debroglie equation. The Debroglie equation says that the wavelength associated with the material particle is h by mv, where this h is the Planck's constant, m is the mass, and v is the velocity. Now, if I proceed from here with the equation for energy, that E is equal to h nu. So, assuming that there is a wave, a train of waves associated with the particle having frequency nu, then this frequency nu will come out to be h by E. Oh, sorry. This nu will come out to be E by h. Where this nu is the frequency of the wave that is assumed here, which is associated with the material particle. And as we also know, this E is equal to mc square. So if I call this 1 and I call this 2, and I compare these two equations, on comparing these two equations, what will I get? I will get this nu will come out to be, instead of E, I will write mc square divided by h. Looking onto this equation, this nu refers to the frequency of the wave associated with the particle. So we know that there is a relation between frequency, wavelength, and the velocity. If I assume that Vp is the velocity of the wave, then this Vp will come out to be, it will be nu lambda. So what will be nu in this case? Nu will be Vp divided by lambda. And I can compare these two equations. If I call this as equation 3, I call this equation 4. I can compare these two equations and I will obtain a result. What will be that result? Instead of nu, I'll be using Vp by lambda. So Vp by lambda will be mc square by h. So what will be Vp? Vp will be mc square by h by lambda. And from Debroglie equation, we know that this h by lambda is mv. So from Debroglie equation itself, we know that this mv is equal to h by lambda. So if I substitute this in this equation, what will I obtain? I will obtain the velocity of the wave, that will be Vp, that will be mc square divide by mv. You can see this m and m will cancel out, and we will get the velocity of this wave. The velocity of this wave will come out to be c square divided by v. Now this equation in itself is a contradiction. You can see that contradiction, that this Vp refers to the wave train that we are associating with the material particle. This velocity is c square by v. So what does this imply? This implies that this Vp is greater than that of c. That means the velocity of the wave that we are assuming here is associated with the material particle is greater than that of speed of light, which is a pure violation, which is a pure contradiction of the predictions of special theory of relativity. And what special theory of relativity assumes is that the speed of light is constant. It's the highest possible speed, and no material particle can have speed equal to that of speed of light. So Vp is greater than this speed of light, which is a violation, which is a contradiction to what is predicted by special theory of relativity. Now this Vp is also called as phase velocity. So this is also called as phase velocity. In other words, if I have to say that there is a wave associated with a material particle, then assuming that the speed of this wave is very, very large than that of the speed of the material particle, then at the same time, the wave will be somewhere and the material particle will be somewhere else. So the idea of a single wave associating with a material particle, which is purely a microscopic particle, does not work, because if we calculate the velocity of the wave associated with this particle, a wave train, it comes out to be greater than that of speed of light. So this way we can say that